This is 6.2 for Honors Math 3, and this is the second assignment or the second set of notes for parabolas. Some sample problems here. We should already know how everything fits together for parabolas at this point. So number one and number two, this is actually for number one and number two, the directions. Write the equation in descriptive form, which descriptive form really is just vertex form. So keep in mind that it's either y equals a times x minus h quantity squared plus k, or x equals a times y minus k quantity squared plus h, or some variation of those, but these are the two that we tend to be working with. And we're also going to sketch and identify its characteristics. So right now, number one is not in vertex form. We can't see what the vertex is. How do we even know whether it's a x equals or a y equals parabola? Well, first off, what's the squared term? Okay, well, the squared term is x squared, so it's going to be y equals. Okay, so now a couple different ways we could do it. I noticed the squared term is positive, and that's kind of nice, so we can work with that the way it is. And I could move everything else to the other side as we complete the square. Yes, we're going to need to complete the square. Or I can get y equals. I think it's a little bit easier if you have the squared term positive already. So x squared plus 10x. And I have that middle term x, so I'm going to need to complete the square. And I'm going to move the y to the other side, so it's negative y, and I'm going to move the 18 to the other side as well, so negative 18. Now, if I have a plus blank on the left side of the equation, I need a plus blank on the right side of the equation just to keep things in balance. And we have completed the square before, so this is not really anything new. Notice I have a positive 1 coefficient for the squared term, and that's what we want typically when we are completing the square. So half the middle term is 5, squared is 25, and to keep things in balance I need to add 25 to the right side of the equation as well. And so now the x squared plus 10x plus 25 factors very nicely as x plus 5 quantity squared. We like that. Negative y plus 7. Now that the square has been completed, now we want to get it into the form y equals. And, it's a negative y right now, so if I move it to the left, it'll become positive y. And I'll move the x plus 5 quantity squared to the right, it becomes negative x plus 5 quantity squared plus 7. And that's descriptive form because we can see the vertex is negative 5, 7. And it's y equals, and it's negative a value, so it's opening down. So we'll keep that in mind. Okay, now sketching it. Negative 5, positive 7. Okay, so my vertex is at negative 5, 7. And if I went 1 point to either side, I'm going down, so 1 point to either side would be 1 point to the left and 1 point to the right. My a value is negative 1, so down 1. And there is the sketch of my parabola. Now let's remind ourselves that the axis of symmetry goes through the vertex, and that's x equals negative 5 for the axis of symmetry. And there's my vertex. And to be able to get the focus in the directrix, I need to calculate the c value. So let's remind ourselves for parabola, c equals 1 over 4a, and the a value is negative 1. I mean, technically we can do the absolute value of the a, so 4 times just a positive 1, or you could do it with a negative 1, and that gives you direction. So the c is negative 1/4, and so it tells me I have to go in a negative direction to go from the HK to a focus. And remember, the focus is always on the inside of the parabola, and the directrix is always on the outside of the parabola, and it's perpendicular to the axis of symmetry, and it's not necessarily exactly to scale here. Okay, now my focus, I just went down a 4th from the vertex. So what changed? Well, the 7 changed. It went down a 4th. So my focus is at negative 5, and then 7 down a 4th would be 6 and 3/4. I'm fine with a mixed number. If you instead want negative 5, comma 27/4, I'm fine with that too. Now, what about the directrix? The directrix is a horizontal line, and every horizontal line is y equals and it's some elevation. Now, if I went down a 4th to get to the focus, that means I have to go up a 4th to get to the directrix because of the definition of parabola. And so from elevation 7 up a 4th, so that would be y equals 7 and 1/4. And there's the equation of the directrix. Could we instead write it y equals 29/4? Sure, but I'm fine with y equals 7 and 1/4 also. Okay, number 2. Okay, what's being squared? Y is being squared, so this is going to be an x equals parabola. So we have 1/4 y squared plus y, and we're going to need to complete the square on y's, and I'm moving the negative x to the side, it's positive x, and the 4 becomes negative 4, and plus blank. Okay, before we complete the square, you want a positive 1 in front of the squared term. And a couple different ways we can do this. Okay, one way we could do it is we could factor a GCF of 1/4 out of the y values over here. So I could do factor out 1/4, and I'd have positive y squared. Now, 1/4 times what gives me positive 1? Well, 1/4 times 4y plus a blank is just plus a blank. And the other side we have x minus 4 plus blank. Okay, so on the inside here I've got positive 1 in front of the squared term, and so that's good. Half of the middle term coefficient is 2, squared is 4, but what do I put on the other side for the blank? It's not a 4, I'm doing 1/4 times 4, which is 1. Okay, and so we have 1/4, and then the y squared plus 4y plus 4, that factors as y plus 2 quantity squared. And the other side we have x minus 3, which, by the way, technically we can see what the vertex is right now, but let's go ahead and get x equals. So 1/4 y plus 2 quantity squared plus 3 equals x. If that bothers you, just have the x move to the left side right now. There it is. There's the equation. It's x equals, so you know it's either left or right. The a value is positive. It is opening to the right. The vertex, so inside the parentheses, what would I plug in to make it 0? Negative 2, but it's a y value, so the vertex is -2 for the y value. And if we plug that in, we get x equals 3. So 3, -2. And so sketching this, -3, -2, there's my vertex. And I'm opening to the right, so if I went 1 point to either side, I'd be going up 1 and down 1, and then going to the right, the a value, which is 1/4, which is not very much. So this one is tending to be on the wide side. And let's remind ourselves that the axis, or the line of symmetry, goes right through the vertex, also goes right through the focus as well. And so the axis of symmetry, horizontal line, y equals, what elevation is that? Y equals -2. And there's the axis of symmetry. Here's my vertex. I need the c value. So c is 1/4a, which is 1/4 times, okay, the a value is 1/4. So that's 1/1. C is 1. So there's a distance of 1 from the HK to the focus. And that means there's a distance of 1 from the vertex, the HK, to the directrix. And it's perpendicular. So x equals 2, we can see. And the focus, okay, so we moved 1 to the right of the vertex, 3, -2. So what changed? Well, the 3 went 1 to the right, so this is 4, -2, that's the focus. And that's what we're supposed to be doing with this one. Okay. Now, by the way, we could talk about the focal chord again. It's been a little bit since we've done the focal chord. Focal chord is parallel to the directrix, goes through the focus, and its length is 4c. And because of symmetry, you've got 2c and 2c. Since c is 1, that distance is 2. My sketch is not real good. You can see this now. So from the focus, I'd be going up 2 and down 2. So this point right here, the focal chord endpoint, should be 4, 0, because it's up 2 from the focus, since c is 1. And this point right here should be 4, -4, because it would be down to total length of 4c. c is 1, so 4 times 1 is 4. And the distance from -4 to 0 is a distance of 4. So you can see there are my focal chord endpoints. Number 3, write the equation for the conic with directrix y equals -3 and focus -5, 1. Now, we did some of these on objective 0, and one way to do it is using the distance formula and all that kind of stuff, but that's really not the way that I would expect you to do it when we get to the test. Now that we understand how everything fits together, I would expect you to do this with a sketch and understanding how it all fits together. So, sketching the situation. So directrix y equals -3, horizontal line, y equals -3, focus -5, 1, so -5, okay, set of all points equidistant from the point and the line. And so the easiest point we can pick out is right there in the middle between it, and that's our vertex. So we can see that our vertex is -5, -1. That's the H and the K. And the focus is always on the inside of the parabola. It opens away from the directrix. So this is a y equals a times x plus 5 quantity squared minus 1. Okay. I know my a value is positive. How am I going to get the a value? Well, let's remind ourselves what the c value is here. So the c value right here is 2. And c equals 1 over 4a. So c is 2. So 8a equals 1. So a is 1/8. And now, with a positive 1/8, there's a negative 1/8. It's opening up. So it's positive 1/8. So y equals 1/8 x plus 5 quantity squared minus 1. Number 4, write the equation for the conic. This is what it's going to be like on the test, because we have parabolas, we have other type of conic sections as well. And it's not going to tell you parabola necessarily. You have to be able to pick through the information and figure out what it is. Write the equation for the conic with focal chord endpoints, and you go, oh, focal chord endpoints, that's parabola. Parabola has focal chord endpoints. And then the a value is negative. So again, let's do a sketch, see what's going on. Okay, so I've got -1, 2, focal chord endpoint, and 15, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now those are the focal chord endpoints. And the focal chord, if you remember, is parallel to the directrix. So my directrix is horizontal. So this must be either an up or down parabola. And right at the middle is the focus. Okay, so if only we knew how to do the middle point of those. Oh, that's right, midpoint. So midpoint, average the x's. So add them up, divide by 2. So -1 plus 15 is 14. Divide by 2, so 7. And the average of 2 and 2 is 2. So my focus is at 7, 2. Which way is this opening? Well, the a value is negative, so it's opening down. Okay, so it's doing something where it's opening down. Not drawing this to scale very well. So my vertex is up here somewhere. And my axis of symmetry goes through those two. Okay, now remember the total length of the focal chord is 4c. And then you have 2c and 2c. Well, what's the total length between those two? The total length between those two, horizontal distance, that's 16, and that's 4c. So c is 16 divided by 4, which is 4. So c is 4. So if I go from 7 to, if I go up 4, my vertex is at 7, 6, and there's my H and K. And let's see, I also know what my C value is right now too. So again, C equals 1 over 4A. So 4 equals 1 over 4A. So 16A equals 1. K equals 1/16, but this one's going down. So A is negative 1/16. Okay, so I think I'm ready to write it. So we've got our HK, 7, comma, 6, and A is negative 1/16, so y equals negative 1/16 times x minus 7 squared plus 6. By the way, don't forget the squared term, because if you forget it, it's not a parabola. So that's rather important, just like we had the squared term on the one before, x plus 5 quantity squared. Okay, last problem here. Write the equation for the parabola with vertex 4, negative 5, horizontal. Okay, they did tell us it's a parabola. Horizontal axis of symmetry. Okay, well, I think a sketch is probably not a bad idea. Helps us get our bearings. So vertex is 4, negative 5. And horizontal axis of symmetry. Okay. Okay, horizontal. So this one must be either a left or right. A point on the curve is negative 8, negative 3. 2, 3, 4, 5, 6, 7, 8. Negative 3. So point on the curve right about there. And here's the vertex. Oh, this one must be opening to the left. Okay, so since it's to the left, I know it's x equals a times y minus k quantity squared plus h. And they told us the vertex. There's the hk. So x equals a times y minus the k minus a negative 5, so plus 5 squared plus h. Oops, wait. They told us the h. The h is 4. Okay, and so we've got most of the problem. Okay, so do we know the focal length? C. Nope. How can we do this? Well, don't forget that they gave us point on the curve. Anytime they give you a point on the curve, it's an x and a y that must work in the equation. So we've been doing this sort of thing all year long so far. So negative 8 goes in for the x, a, and in for the y is the negative 3 plus 5 quantity squared plus 4. Okay, so I'd probably subtract 4 right now. We got negative 12 equals a times, okay, negative 3 plus 5 is 2, squared is 4. And so a is negative 12 over 4, which is negative 3. And so if we plug that in for the a value, we will have equation x equals negative 3 times y plus 5 quantity squared plus 4. And there's the equation, which seems to make sense, because if I went one point to either side of the vertex, and if I go 3 to the left, then that seems about right for this equation. Okay, so worksheet 2, which is Parabola worksheet 2 in the packet.